How many workstations are needed to balance a line? The required number of workstations depends on several parameters. One of them is the desired output rate. What you would want to be the desired output rate. And also our ability to bundle up tasks and put them in a workstation. These are the two main parameters here. So we can actually, based on these consideration, we can compute the theoretical minimum number of stations. Why do we want to minimize the number of workstations? Well, to actually save, for example, labor, because each workstation needs to have a worker operator to work on. So the minimum number of workstation can be computed using this formula. So n sub min, that's the theoretical minimum number of workstations, and t here is the processing time of a task. So you would have to sum up all the processing time, the task that you have in hand, and then divide that by the cycle time, knowing what desired output rate you want. When you balance a line, as you remember, there are different, many actually scenarios that you can bundle tasks together. So out of those options, we would want to see, okay, what is the measure, what is the judgment here, so that we can distinguish between these and take the one that is best. How we can judge this? So here we want to talk about the measures of effectiveness. The one of them is the balance delay, which is the percentage of idle time. You won't want to make the utilization of your system maximum. You want to, that means that you want to minimize the idle time, because that's the waste of resources. So one measure of effectiveness of a balanced line is the percentage of idle time of a line, and it is computed using this formula. So balance delay is idle time per cycle divided by the number of um, stations that you have, multiplied by the cycle time, and it's going to give you a percentage. You have to multiply by 100, so we get a percentage here. The other measure is the efficiency. Efficiency is the percentage of busy time of a line. So these two actually are complement to each other. So efficiency is 100% minus the balance delay. That means the whatever actually your idle time is you actually subtract it from the 100%. That's going to give you the percentage of busy time. So you want to maximize efficiency and you want to minimize the balance delay. So they're not really different from each other in that perspective. So as we learned, there are so many options how to design workstation or how to bundle tasks together considering the precedence diagram. But which of these designs should we pick? Which one is better? And how we actually do that? So there are actually no optimal way to do this if you have a lot of options. Um, but simply, you can actually compute the cycle time or the output rate of each design and then pick the one that is the most optimal or the best one. But if you have a lot of tasks, for example, if you have thousands of tasks, then there is no way actually you can do that. You would have to compute every possibility for those um, thousands of tasks. So there is no really optimal way to do that, or efficient optimal way to do that. So in realistically and practically, um, companies or businesses, they use some heuristics, or which is some intuitive rules to find the not the best one, but the possible best one. So we're going to learn about these heuristics. The first one is the most following tasks, the first heuristic. And it works as such that you assign tasks in the order of the most following task. So count the number of tasks that would follow a task. And the other method or the other heuristics, it works as the greatest positional weight. So you would assign tasks in order of the positional weight. The greatest positional weight would have priority. So positional weight is what the positional weight is the summation of each task time, process time, and the times of the following task. So let's see how these heuristics work. Let's start off with the first algorithm in line balancing, the most following. So the challenge is after you set aside, okay, what is the theoretical number of workstation that you want, is which task you would have to assign to which of these workstations. So that's what this algorithm is going to tell us. So let's see how this algorithm works. The amount of time, this is the important to note, it's like one of the constraints. The amount of time available to each workstation is set to the cycle time. So that means that you cannot assign more load of work to a workstation bigger than the cycle time. So the first step is begin with the task with the most following number of tasks and assign it to the first workstation. So you start out with the first workstation and then you look at to see, okay, which one of these tasks should I add to workstation 1? Well, the algorithm says that, okay, find the task with the most following number of tasks and assign it to the workstation 1, the first workstation. So you need to actually do a little bit computation to find the number of following tasks for each task, and then the one that has the most following, you're going to add it to the workstation 1. The second step is move to the next task with the most following. So you're going to prioritize or rank the task based on the most following number of tasks. The first one, the task with the most following goes to the station, the first station. The next one, the most following, the second most following is going to go next. And if it's possible, assign it to the current workstation. If it still has a room, considering the cycle time and the first task that you asked to it. Otherwise, assign it to the next workstation. And repeat this process until you have assigned all the tasks. So we're going to do an example to see how this works in practice. Let's do this example. So we want to use the most following task algorithm to balance all the tasks for this particular problem. The cycle time is set to be 1 minute. So please pause, try to look back at the algorithm and try to work this out on your own, and then come back to see the solution after you're done. Right, let's work out this example. The first step to do here, we need to figure out the number of workstation, the theoretical number of workstation. So we know that the cycle time is 1, and according to the formula, the theoretical number of workstation and submean, the minimum number of workstation, that's equal to the summation of processing time of all tasks divided by cycle time. So what is the summation of processing time? Processing time, that's 0.1 plus 1 plus 0.7 plus 0.5 plus 0.2. And that's actually equal to 2.5 minutes. So this is 2.5 minutes divided by cycle time, which is 1. So the theoretical minimum number of workstation is 2.5, but we need to round it up because 2.15 workstation doesn't mean anything. So that means that the number of workstation is 3. Right. Now that we know the number of workstation, we're going to do the assignment of tasks to the workstation based on the most following algorithm. I'm going to use this table here to do each step of the algorithm. So let me fill out the first column, the first row, which is the head of this table. So the first column is the workstation. Which workstation? That's the task that we want to do. We want to assign, okay, we have 3 workstations. which of these tasks should go to which of these workstation. So the first column is the which workstation. The second column is time remaining, which for all workstation starts with 1 minute, and that's the cycle time, the maximum time allowed, or the maximum workload allowed for each workstation is 1 minute. Eligible, the third column is eligible, which tasks are eligible to assign to which workstation. And the next one is assign. Okay, out of these, which one you should assign. The next one is time remaining at workstation after the assignment, and the last one is idle time, which is time left out at workstation after you assign all of the tasks possible before you close that workstation. So let's go ahead and get started with workstation number 1. So the time for workstation 1 is 1 minute, the cycle time. What are the eligible tasks here? So this shows the constraint that we have in assignment of tasks. So we cannot start with task B or task D or task E because of the precedence constraint or precedence relationship. We can only start with task A and task C because these are the first tasks. For task B, D, E, they need to have the previous task assigned or completed first. So the only eligible tasks here are tasks A and C. Which one should we assign, task A or task C? So this is where we use the most following. For task A, we have 1, 2, 3 tasks. So task A has 3 following tasks. Task C, on the other hand, has 1 and 2. So which one is bigger? Task A has more following tasks. So we're going to assign task A to workstation 1. How many time left out if we assign as task A? The task A would require 0.1 minute of processing time. So this means that if we assign it to workstation 1, there's going to be 1 minus 0.1 or 0.9 minutes left in the workstation 1. This is task 1, workstation 1. Okay. Now that we assigned task A, what are the eligible tasks? Well, task B and task C are eligible. B and C. Which one should we assign? Well, both of these, both B and C, they have only 2 following tasks. So they are equal in the number of following tasks. We don't have any the most following. So this means that you can assign actually either. I'm going to go with task C because we also had it before as an eligible task in the previous step. You can go with B, it doesn't matter. Okay. The time remaining, if you assign task C, that's 0.7 minutes. It's going to cost or take time. So 0.7, that's 0.9 minus 0.7, that's 0.2. So 0.2 minutes here. You're going to have 0.2 minutes here at workstation 1. All right. Now that we assigned task C to workstation 1, how many tasks are eligible here? Well, task B is eligible, task D is not, because D needs B to be completed. So the only eligible task right now is task B. Can we assign it to workstation 1? Well, task B would require actually 1 minute of processing time. So, and we only have 0.2 minutes at workstation 1. So we cannot really actually assign this. Okay, so we're not going to assign it, and we're going to left out with 0.2 minutes at workstation 1, and we're going to close this. All right, we're going to open workstation 2. We have 1 minute, the cycle time available. The eligible task is B, and we're going to assign it because it's just 1, and it would require 1 minute. So 1 minus 1 minute here and 1 minute for task B, so that means that we have 0 left here. So we're going to actually close workstation 2 by assigning only one task here. So we're going to open up workstation 3. We have 1 minute the cycle time available. And since we assign task B, we only have one eligible task and task D. And since this is just one, we're going to assign task D to workstation 3, and that would require 0.5 minutes. So the time left would be 1 minute minus 0.5, that's 0.5 minutes left here. And I'm gonna go to again here, so that's 0.5 minutes here. So we assigned the task D to workstation 3, and the only eligible task left is E. We're gonna assign it. Can we assign it first? We need to see if we can assign it. It's 0.2 minutes. And we have 0.5 minutes here. So we can actually assign it. So we're going to go ahead and assign task E to workstation 3, and the time remaining would be 0.5 minus 0.2. That's 0.5 minus 0.2, which is 0.3. So we are actually done with all the assignment. There is no other task left out for us. So we're going to actually close this workstation 3 as well, and we're going to have 0.3 idle time here. So our assignment is done. This is how it will look like. Task A and C are assigned to workstation 1. So this is workstation 1. Task B is actually set at workstation 2. So this is workstation 2, and task D and E are assigned to workstation 3. So this is workstation 3. All right, this is a nice and typed out version of the solution. The most following algorithm, as you see here, we have done all the steps, the 3 workstation and the time remaining. All of these table that we did here is actually typed out in a nice way, and also the workstation assignment, task assignment is shown here, which is more eligible and also more easier, actually cleaner to see. And also the total number of idle time is 0.2 here and 0.3, which is 0.5 minutes total idle time. We can compute the efficiency for our current assignment.